Good morning, learners. Today we are going to study about upper bound and lower bound of our measurement. What do you mean by upper bound and lower bound? It means that is the range that our actual measure of the object lies. So let's have an example here. Number one, we have 10 centimeter and this measurement is correct to the nearest centimeters, or it is correct to the nearest unit digit. So the unit digit is this one. So we have 10 centimeter here. This is for the upper bound and this one is for the lower bound. First, we get the accuracy. So what is the accuracy of this one? Nearest centimeter is also the same as unit digit. This one, 1, 2, 3, 4 up to 9. So when we have a unit digit, it means that we are dealing with 1. In the tens digit, we are dealing with 10. In the hundreds digits, we are dealing with hundreds, thousands, thousands. So we have 1 and we are going to divide this by 2 and that gives us 0.5. This range 0.5 will be added to the 10 to get the upper bound and subtract from 10 to get the lower bound. So for the upper bound, we have 10 and we are going to add that 0.5. So we have 0.5 here. So our upper bound is 10.5 centimeters. And for the lower bound, we have 10. We need to subtract that 0.5 here. That will give us 9.5 centimeters. To check whether your answer, the upper bound and the lower bounds are correct, we subtract 9.5 from 10.5 and we will get that 1. What do you mean by this measurement? It means that the maximum is 10.5 but the 10.5 is not included in the actual measurement, because if we are going to round off this one, it will become 11. So 10.5 is just only for computation but not included. But the 9.5 is included because if we are going to round off the 9.5, we will get the 10. So if we are going to write, this one is the length, so we can write that one as length is equal or greater than the 9.5 here, but less than the 10.5. So the range of our actual measure of the object is from 9.5 to less than 10.5, because 10.5 is not included. It is used only for the computation. So you have the upper bound and the lower bound. Okay, number 2, we have 22.5. What is this one? This one is the tenths. So that is 0.1. The accuracy of this one, because this one, to 1 decimal place. So 1 decimal place, or this one is correct to the nearest tenths. This one is tenths, or correct to 3 significant figures, 1, 2, 3. So this one's a third, the 3 significant figures. So let us have the accuracy. It's 0.1, not 1 anymore. It's 0.1. That's the accuracy. Tenths. So we have 0.1. What do we do with the 0.1? We divide it by 2 always. So we have this one, and it will give us 0.05. So we will add that 0.05 to 22.5 to get the upper bound. 22.5 plus the 0.05 I mean. So here we will have 22.55. And then in the lower part, we have 22.5 minus that 0.05. So this one is 22. The shortcut is you just subtract 1 here and add a 5. The upper bound is you just copy this one and add 5. So we have this one and this one. 22.55 minus 22.45 will give us 0.1 or 0.10. Okay, number 4, 128,000, correct to 3 significant figures. 1, 2, 3. Here we don't have the decimal point, therefore we have only 3 significant figures here. If we put the decimal point there, it becomes 6 significant figures. So here, that one is correct up to this one. And what is this 8? That is 1,000. So let us get the accuracy, which is 1,000. So we have 1,000, always divide by 2, and we have 500. So what am I going to do with the 500? We add that one to get the upper bound. We have 128,000 plus the 500 here. So that would be equal to 128,000 plus 500 is 128,500. And the lower bound is 128,000. We subtract that 500 there. So this one will give us 127,500. Okay, to check 128,500 minus 127,500, and we will get 1,000. So this one is 1,000. So our upper bound and lower bounds are correct. Number 5, we have 4,240. In significant figures, we have 3 significant figures here. And the problem is find the upper bound and lower bound correct. If this one is correct to the nearest 500s. So 500s is in this column here, the hundreds. So 500s. So we have accuracy of 500 divided by 2 is equal to 250. And then we have 4,240 here. Let's have the upper bound, which is 4,240 plus that 250 there would give us 4,490. And then the lower bound is 4,240. We subtract that 250 here, and that would give us 3,990. To check, 4,490 minus 3,990, it will give us that 500 here, the lower bound. So we have this problem. A is equal to 3.6, correct to 1 decimal place, and B is 14, correct to the nearest whole number, or correct to the nearest unit digit. We will find the upper and lower bound of the following. Number 1, 2, 3, 4, 5. So let's start with A plus B. But before that, we are going to have first the upper bound and the lower bound of A and B. So let's have the A here. Okay, you can put the A here. And let's have the upper bound here and the lower bound of A. 3.6 up to 1 decimal place. So we have 3 point, you just add 5 here for the upper. And then 3 point, subtract 1, 50, and then add 5. So you have the upper and the lower bound of A. What about the B? Our B, we have the upper and the lower. 14, the upper is 14.5 and the lower is 13.5. So I have the upper, lower, and of A and B. Okay, let's have number 1. For number 1, okay, put here. We have A plus B. Let's have the upper here and the lower here. To get the upper, what do we do if we are going to add A and B? We will add both the upper to get the upper. Okay? If we want the lower, then we add the lower and the lower. So for the upper, we have 3.65 plus that 14.5 will give us, and then get your calculator now, we will compute. We have 3.65 plus 14.5, and then we have 18.15. So this one is 18.15, the upper bound. The lower bound of this one is both lower, minimum and minimum. So we're going to add 3, this one, 0.55 plus 13.5. So that one is 3.55 plus 13.5 is equal to 17.05. Number 2, we have A times B. To get the upper bound, we have to multiply the upper bounds of A and B. So we have 3.65 times 14.5. For the lower bound here, we will multiply the lower bounds. We have the 3.55 times the 13.5. So we have 3.65 times 14.5, 52.925. And for the lower bound, we have 3.55 times 13.5, and we have 47.925 here. Okay, number 3, this one is minus, so it is a little bit tricky. Now to get the upper bound, the maximum, we need this one to be the highest, or the upper, minus the lower, so we can get the maximum value here. So the B, for the B, we need the upper, which is 14.5. Minus for A, we need the lower, 3.55. Okay, for the lower, here, we need the B, the lower B. We have 13.5. And we subtract the upper of A, which is 3.65. So that our answer here will be the smallest, because this one is the smallest B, or the minimum B, and then we subtract the biggest A, or the maximum A, so we get the smallest here, 10.95. So this one is the upper bound of A minus B. And then 13.5 minus 3.65, is 9.85. Okay, this one is 9.85. Okay, number 4, this one is division. To get the upper bound, we need this one to be the upper or the larger one divided by the smaller to have a bigger or larger number. So A is the upper, which is 3.65 over 13.5 here. For the smaller or for the lower bound, we need this one to be smaller, this the minimum, which is 3.55, and we will divide this by the maximum or the larger number of B, which is 14.5. Point 703, that's the upper bound, and then the lower bound is 0.2448. Okay, for number 5, we have A plus B divided by A. So for the upper bound, we need this one to be the upper of this. Let's have this one, upper of A, which is 3.65, plus the upper of B, which is 14.5, and then we are going to divide it by, so A is 3.55 here. And for the lower bound, we need the smallest possible value for A and B, which is 3.55 plus 13.5, and then we divide this by A, which is the 3.65. So we have 3.65. Okay, take note of this one. So we add first and then we divide. We add this. This one is 3.55. This one is 3.65. So let's add the top one and 15 here. The one that we solved earlier, 5.1105, and then divide it by 67, and that is the application of the upper bound and the lower bound.